Hey guys, what's up? Welcome to another Unity tutorial. Today we're going to build an awesome dash mechanic for your third-person character. If you've already got basic movement in Cinemachine set up, you'll find this super easy to follow along with. By the time we're done, your character will be zipping around with smooth directional dashes that you can customize however you want. Plus, we'll add some sick visual effects to make it look professional. So let's dive right in. First things first, we need to create a new script. Let's call it player-controller and open it up in our code editor. Inside the awake method, we'll start by grabbing a reference to the rigid body component, which we'll need for all the physics stuff we're about to implement. Next, we need to add some variables to control how our dash works. I like to use the header attribute to keep everything organized. Trust me, your future self will thank you for this. Under our dash settings section, we'll need several key variables. Dash force determines how powerful the dash is. Dash duration controls how long each dash lasts. Dash cooldown sets the waiting time before you can dash again. Max dash charges allows you to do multiple dashes. And dash charge refill time defines how quickly those charges come back. We also need some direction settings to make the dash feel just right. The use movement direction option makes your character dash in the direction they're moving, while use camera direction makes the dash follow your camera's forward direction instead. Now let's set up the input system. Make sure you've created an input map with a dash action and the player action map. If you haven't done this yet, go ahead and pause the video to set it up real quick, then come back. After that's done, we'll add a reference to your input system actions and the camera's transform, which we'll need for camera relative dashing. We also need some state variables to keep track of what's happening with our dash. The dash direction vector3 stores which way we're dashing is a Boolean flag that tells us if we're currently in the middle of a dash. Can dash is another Boolean that controls whether the player is allowed to dash right now. Current dash charges keeps count of how many dash charges the player has available, and original drag stores the character's original drag value so we can reset it after dashing. These state variables are super important because they'll track the dash state throughout the game, updating as the player dashes, waits for cooldowns, and recharges. Moving on to initialization, we'll grab the main camera, set our initial dash charge count, and save the original drag value. The enable and undisable methods make sure our input actions turn on and off when they should. Now we'll add a method called onDashPerformed. In this method, we'll also subscribe to the dash input action event and initialize input actions, which I almost forgot about. Here comes the fun part. When the player hits the dash button, we run a quick check to see if they're allowed to dash and have charges available. If both conditions are met, we kick off our dash coroutine. This dash coroutine is where all the magic happens. First, we set the dash state and use up one charge. Then we calculate which direction to dash, which we'll implement in just a moment. After that, we tweak the physics by turning off gravity and setting drive to 0 for a super smooth dash. Next, we apply the dash force to the rigid body, followed by a while that waits for the dash duration. When the dash ends, we reset all the physics stuff back to normal, start the cooldown coroutine, and if the current dash charge is smaller than max dash charges, we start the recharge coroutine too. For calculating the dash direction, we have a few options. If use movement direction is on, we use the player's movement input. If there's no movement input or use movement direction is off, we just dash forward. When use camera direction is on, we make everything relative to where the camera is pointing. And to keep things consistent, we always zero out the Y component and normalize the direction, which keeps the dash on a horizontal plane. To handle the tiny aspects, we've got two coroutine. The dash cooldown coroutine waits for the cooldown period before allowing another dash, while the refill dash charge waits for the refill time before giving you another dash charge and keeps calling itself until you're maxed out. Let's test what we've got so far. Make sure you attach the script to your character and set some values in the inspector. This is the perfect time to play around with the dash for duration and cooldown until it feels just right for your game. Now that our basic dash is working, let's make it look awesome with some visual effects. First up is a trail renderer. Under a new visual feedback section, add a variable to reference a trail renderer component. Head back to Unity and add a trail renderer to your character if you haven't already done so. I've already configured one, but Make sure to add it to your player and drag it into the dash trail field in our component. To keep everything clean, we'll make sure the trail isn't emitting when we start the game. Then in our dash coroutine, we'll turn it on at the start of the dash and off when it ends. Let's test it out and see how it looks. That's looking pretty sweet already. It's actually really fun to play with this dash effect. To add even more juice, let's include a particle system. Add another variable to reference a particle system component. Similar to the trail renderer, we'll play the particle effect when the dash starts. I've already created a basic particle system for this tutorial, but feel free to customize yours however you want. Go wild with it. Drag your particle system to the dash particles field in the player dash controller component. For now, I'm going to remove the trail renderer reference and deactivate it. Let's run the game and try to dash. Awesome. It's working like a charm. We're making great progress, but let's take it up another notch with a stylish after-image effect. This will leave a ghostly trail behind your character when you dash, making it look even cooler. Under the visual feedback section, add these variables. Dash after image for a prefab of the after image. Dash material for the material to use during the dash. After image duration to control how long each after image lasts. After image count to set how many after images to spawn, and time between after images to define the time between spawning them. Now we need a way to handle the fading of these after images. Let's create a new script called dash after image with these variables. Fade duration controls how long it takes for the after image to completely fade out. Renderer stores all the mesh renderers attached to the character and its children. Materials holds the materials of each renderer and start time captures when the after image is created. In the awake method of this new script, we gather all the mesh renderers and their materials so we can control the fade out effect properly. When the after image spawns, we record the starting time. Then every frame, we calculate a value called t that goes from 0 to 1 over the fade duration. Using this value, we adjust the alpha of each material, starting at half opacity and gradually fading to completely invisible. Once the fade is complete, the after image destroys itself to keep things clean and performant. To set up the after image system, start by duplicating your character model. Then strip away everything except the mesh renderers and add the dash after image script to it. Create a transparent material with your favorite color. I've already made one. Then drag the duplicate to your project panel to create a prefab. Assign this prefab to the dash after image field in your player dash controller. Delete the duplicate from the scene, and finally fill the dash material field with our material. Don't forget to add the script we just created to the prefab and set a value for the duration. Now let's update our player dash controller script. We'll update the awake method to store references to the mesh renderer and its original material. Then we'll create a new coroutine that spawns after images during the dash. In this coroutine, we loop through the number of after images we want, instantiate the prefab at the current position, set it to self-destruct after the duration, and wait before creating the next one. Finally, we'll update the dash coroutine to change the character's material during the dash. Start creating after images and restore the original material when done. Let's give it a test run and see how it looks. It already looks amazing, but to really amplify the impact and make it feel even more dynamic and powerful, let's incorporate some camera shake and file adjustments using Cinemachine. Create a camera effects section with these variables. Camera impulse gives us a reference to a Cinemachine impulse source for camera shake. Dash FOV change controls how much to increase the field of view during the dash. And FOV change duration sets how long the FOV change lasts. Next, we'll update the awake method to grab references to the Cinemachine components and save the default FOV for later use. Let's make a new coroutine that handles the FOV change. It will store the starting FOV, gradually interpolate to the target FOV, and make sure the FOV is exactly set to the target value at the end. Then we'll update the dash coroutine to trigger a camera impulse for screen shake, increase the FOV during the dash, and reset to the default FOV when the dash is done. Now we need to set up the Cinemachine impulse component in Unity. Select your character and add a Cinemachine impulse source. I'll set the impulse shape to rumble and leave the other values as they are. Then select your Cinemachine virtual camera, add a Cinemachine impulse listener, and drag this component to the camera impulse field in the player dash controller. We're almost done. Let's add some helper methods so other scripts can interact with our dash system. These methods will let other scripts check if the player is currently dashing, get the current number of dash charges, get the cooldown progress as a percentage, and get the charge refill progress as a percentage. These can be super helpful for UI elements or other gameplay mechanics that need to know about the dash state. All right, moment of truth. Let's test our complete dash system. Looking good. Everything is working perfectly. You now have a professional dash system with directional dashing, multiple dash charges with cooldown, visual feedback with trail renderer, particles, and those sick after images, plus camera effects with Cinemachine. The best part is how customizable this is through the inspector. You can tweak all the values to get exactly the feel you want for your game. And you can easily add more features like sound effects or special gameplay mechanics that trigger when you dash. That's it for today's tutorial. Drop a like if this helped you out, and let me know in the comments what other mechanics you'd like to see in future videos. Later!